First, the pH scale. Many of you might be familiar with the pH scale already because you learned it in middle school. However, it's always a good reminder to go back and relearn. The pH scale is used to tell us how acidic a substance is. You might have heard of something has a pH of 6 or a pH of 5. Those are examples of telling us how acidic something might be. Now what pH scale is actually doing is it's measuring the concentration of hydrogen ions in a solution. Remember, what makes something acidic is how much hydrogen it has. And so what the pH scale does is measure that concentration. To summarize, the more hydrogen ions there are in a solution, the more acidic that it's going to be. On the flip side of that, the less hydrogen ions, the less acidic. A good way of looking at pH, if it helps, is think pH measures the power of the hydrogen, or how strong the hydrogen is. Pause the video and allow everyone to write this down, then hit play to move to the next slide. The pH scale runs from 0 to 14, as some of you might have recalled. Anything from 0 to 6, in fact up to 6.99999 repeating, would be acidic. 7, which is right in the middle, is neutral. And 8 to 14 is going to be basic. There are very few things in the world that are purely neutral. Even water that comes out of the sink is not completely neutral, but in fact has acidic properties to it. Note, the further and further you get away from the neutral point, which is 7, whether in the base direction or in the acid direction, it gets stronger. Therefore, the strongest acid would have a pH of 0, and the strongest base would have a pH of 14. Notice the scale that's up on the board. This is actually in your textbook on page 653, which should be open in front of you. If not, go ahead and open to it now. Notice at the very top, it tells you two things. The very top tells you the hydrogen concentration, and then below it, it tells you the pH. Notice that the hydrogen concentration is given to you in scientific notation. It goes from 1 to 10 to the negative first, to 10 to the negative second, all the way down to 10 to the negative 14th. To help you out for those that do not like scientific notation, I'm just going to write a few of those in standard form so you get the idea. 1 would remain as 1, but 10 to the negative first would be 0.1. Then it would move to 0.01. Then it would move to 0.001. And it would continue going all the way down to 10 to the negative 14th, which would be 0.00000000000000001. You get the idea. It's a lot of zeros. Now notice what's happening to the concentration of hydrogen as you move from left to right. Hopefully you can see that the hydrogen concentration is getting much, much lower. Since it's getting much, much lower, that means as we move from left to right, the pH must be telling us that the acid is getting weaker and weaker. And that's why you notice that it moves from the red color to the blue color. Because the weaker the acid, really what you're saying is it's getting more basic. Now I want you to notice a pattern about the number for the concentration and the pH. Let's take, for instance, 8. Look at where the concentration of hydrogen is 10 to the negative 8. What is its pH? Well, it's 8. Do you notice a pattern? Hopefully you're noticing that the pH goes right along with what the exponent would be. So 10 to the negative 4th, for example, is going to have a pH of 4. 10 to the negative 11th is going to have a pH of 11, and so on. So there is a correlation between hydrogen concentration and the pH. Now we've been only looking at the top part. What about the bottom part? There's information down there too. The bottom part has to deal with pOH and hydroxide concentration. This is something that is probably not as familiar. In middle school, you usually only go over pH, but you never talk about something that is pOH. The pOH scale is very, very similar in that it measures concentration and tells you how acidic or basic something is. But it's flipped. It's flipped because instead of focusing now on hydrogen, it's focusing on hydroxide. Let's take a look at that. We started with the pH scale. Let's now look at the pOH scale. The pOH scale is used just like the pH scale in that it is measuring strength of a substance. But it's not measuring to see how acidic something is, but instead how basic something is. In other words, it's measuring the concentration of hydroxide in a solution. So let's compare this to the pH scale. pH scale measured hydrogen. pOH scale measures hydroxide. The more hydroxide ions that are in a solution, the more basic that it will be. Please note that this is the exact opposite of the pH scale. At this point, pause the video if anyone is still taking notes, then hit play to resume. If we look at the pOH scale, notice it still goes from 0 to 14 because pH and pOH do go hand in hand. However, it's flipped. If you have a pOH between 0 and 6, it's basic. If it's 7, it's still neutral because it's in the middle, but 8 to 14 would be acidic. Notice once again, this is for pOH, not for pH. Let's go back to that chart so we can actually take a look at what is going on. All right, we started out with looking at the top part where hydrogen concentration told us about pH. Now let's look at the bottom. It now has pOH. Once again, it is measuring hydroxide concentration, but notice that it's flipped. It starts out down here with the very low number, the 0.0000000000001 molarity of hydroxide. Not a lot of hydroxide here, but as we move down, it goes up to 1, which would be a lot of hydroxide. That's why the pOH is 0. All I want you to notice is that the pH and the pOH do go hand in hand. We'll come back to this in a second, but let's go ahead and look at something. Notice the relationship between pH and pOH. For instance, what do you get when you add 0 and 14? Well, 14. What do you get when you add 4 and 10? 14. What about 9 and 5? 14. 12 and 2? 14. And so on. You get the picture. We notice a very key relationship that's going to help us in the future. We know that pH is a measurement of hydrogen and pOH is a measurement of OH, or hydroxide. But when you add them together, it should always equal 14. Therefore, we can use this relationship to help us figure out missing information. For instance, if I told you that something had a pH of 3, what would its pOH be? Hopefully you can figure out that 14 minus 3 would be 11. Would this solution be acidic or would it be basic? The answer is acidic, and you can find that out by looking at pH or pOH. The pH is 3, which is less than 7, and the pOH is 11, which is greater than 7. According to your notes, both of those line up with an acidic property. My trick is to always look at the pH, since that one is more commonly used. I base everything off of the pH just because it's easier to remember. If the pH is less than 7, it's acidic. If it's higher than 7, it's basic. And remember, pOH will always just be the opposite of that. Notice in this picture here, I have two solutions, one on the left, one on the right. Which one would be acidic and which one would be basic? The one on the left, since it has a lot of hydrogen, would be acidic, and therefore would have a low pH, because remember, the lower the pH, the more acidic. The one on the right would be more basic, because it has more hydroxide, and therefore it would have a high pH. Now let's do some practice. What I've given you on the screen is I've given you some blanks with some given information. What I'd like you to do is I'd like you to fill in the missing information and then determine if it's an acid or a base. I'll do the first one for you, and then you do the remaining 3. All right, let's take a look at the first one. All it tells us is that we have a pH of 8. We're supposed to fill out the rest of the information based off that one piece of information. Okay, well remember, the chart tells us that hydrogen concentration and pH value goes together, and hydroxide concentration and pOH go together. So we're going to use that to help us out. I know the pH is 8, which must mean the hydrogen concentration is 10 to the negative 8, because remember, there was that relationship in between. If I know the pH is 8, remember, pH and pOH together must equal 14. So 8 plus what would give you 14? The answer to that is 6. And if my pOH is 6, then that must be my hydroxide concentration, which go together with the pOH, is 10 to the negative 6. Final question. Is it an acid or is it a base? Remember, I think it's easier just to look at the pH value. My pH value was 8, and that one is higher than 7. Since it is higher, this is basic. Now go ahead and pause the video and take the time on your whiteboards to finish the rest of these 3 columns. When you want the answers, hit play. For the second one, my hydrogen concentration is 10 to the negative 1st, which means my pH is 1. If my pH is 1, my pOH must be 13, and therefore hydroxide concentration is 10 to the negative 13. Since my pH was 1, that is definitely lower than 7, and that is acidic. For the third one, it starts out giving me my pOH, and that is a typo. I apologize. The pOH, this should be over here. That should be concentration, which means the pOH should be 3. That is my apologies. pOH is 3, which means my pH would be 11, and therefore the concentration would be 10 to the negative 11th. Is this acidic or is it basic? The pH is definitely greater than 7, and therefore it is basic. Finally, and hopefully you figured this out, 14 should be in that column. The pOH is 14, which means my hydroxide concentration is 10 to the negative 14th. If my pOH was 14, that means my pH is 0, and therefore 10 to the 0 is just 1. This solution is definitely acidic.